Alright, welcome to 2-1, solving linear systems in slope-intercept form. Now, in example 1, you're actually going to think, well, wait a second, this doesn't really look like a linear system. This kind of looks like the problems that we've been solving. We have 4x minus 7 equals negative 3x plus 4. So why would that actually be a linear system? Well, if I were to look at the function, in fact, let me switch colors. If I were to look at the function 4x, f of x equals 4x minus 7, I notice that it's actually a line. And if I were to look at the function that is negative 3x plus 12, see this negative 3x plus 12, I know that it is also a line, and these two lines, they meet. And so essentially, whenever we've been solving problems like this, that you've been seeing this whole class period, well, we've actually been solving a system of equations, and you just really haven't known it. Now, what we're really trying to find out is where are those two lines crossing? Okay, so let's take a look here. So we have 4x minus 7 equals negative 3x plus 12. What are we going to do? Well, the first thing we're going to do is we're going to move our smaller x, of course. And so I will add 3x to both sides. I'll add 3x to both sides. And I'm going to try and shift this over a little bit to the left. So I have 4x plus 3x is 7x minus 7 equals 12. Okay, well from here we just want to get x by itself, so we'll add 7 to both sides, we'll add 7 to both sides, and now we have this, we have 7x equals 12 plus 7 is 19. Now in order to finish this up, all we'll do is divide both sides by 7, and we're actually going to get kind of a weird number. We're going to get that x equals 19 over 7. Okay, now let's take this one step further though. We actually know that every single point is made up of an x and a y. I hope you can see that on the white. In fact, let me switch to a sharper color. We know that every point is made up of an x and a y. So we found the x value, check, but now we have to find the y value. And how are we going to find the y value? Well, we're going to take that x value and we're going to plug it into either one of these functions. It doesn't really matter. So let's go ahead and let's plug it into this one, f of x equals 4x minus 7. Okay, so I'm going to start this off, and actually I would encourage you to pause this. I'm going to clear this off so it looks just a little bit nicer and neater. So pause it if you have to. Okay, so we have x equals 19 over 7, and we're going to choose which function to plug it into. Of course, let me switch it off the eraser. So right here I have f of x is equal to 4x minus 7, and let's just go ahead and do that one. So we'll write f of x is equal to 4x minus 7. And notice I'm leaving my spaces where x would go, I'm leaving them blank. So we plug in that f of x, 19 over 7, or I'm sorry, that x value, and we plug in 19 over 7 right here. And now we just have to simplify that right hand side. So we'd say f of 19 over 7 is equal to 4 times 19 over 7. Well, we can easily change that into 4 over 1. And so we do top times top. We have 4 times 19, which should give us 76. You can test me on that one. And on the bottom, 1 times 7, which would be 7, minus 7. Now notice here, this is really 7 over 1. So we actually are going to have to get a common denominator. Let's switch this red. And so the question becomes, if we want to multiply this 1 on the bottom right here, 1 times what number would get us to 7? Well, do 1 times 7. And if I multiply the bottom by 7, I'll multiply the top by 7. Okay, easy. And so now we have this final line, f of 19 over 7 is equal to 76 over 7 minus, and we know 7 times 7 is 49 over, on the bottom, 1 times 7, 7. And like we've been doing all day with fractions, well, 76 minus 49 will give us, I don't have a calculator handy, so 76 minus 49 will give us 27. And so we'll get 27 over 7. Now this is our x value right here, the 19 over 7, and this is our y value, the 27 over 7. And now we have our solution. These are actually crossing at 19 over 7, comma, 27 over 7. Now, the reason that I chose such a horrible fraction to start things off is because I want you to notice right here, this point where they cross, it's not a perfect integer. So why do you have to know the algebra? You have to know the algebra whenever two lines cross at non-perfect integer points, i.e. decimals or fractions. All right, now let's move on to our second example where we can really put this together. Okay, here we are in example 2. And this is the key. This is like really going to teach you how to actually do these problems. So we want to solve the system y equals 3x minus 4 and y equals negative 2x plus 6. And so let's do this first of all. Let's kind of ideally label these on the graph. Here we could say that this f of x, well wait a second, this has a y-intercept of negative 4 and this has a y-intercept of negative 4. So this must be f of x is equal to 3x minus 4. And over here, this one has a y-intercept of 6, so clearly this one is the negative 2x plus 6. Now check out the point where they're crossing. Could you already tell me where it's at? Yeah, you can say, okay, 1, 2, and 2, 2. This is at the point 2, 2. So graphically, we can tell where the answer is, and that's so key. Now, let's use some algebra. I want y'all to check this out. I'm going to rewrite this a little funky. We know that 3x minus 4 is equal to y. Using a different color though, we also know, see this y right here? We also know that y is also equal to negative 2x plus 6. Well, in math we have something called the transitive property, which basically states that if a is equal to b and b is equal to c, well then a must equal to c, aka we can cut out this y and we can just say, okay, 3x minus 4 is equal to negative 2x plus 6. Look, when this equals y and this equals y, these two things have to equal each other. Now from here, we'll just go through our standard rules. We move our smaller x, we add 2x to both sides, 3x plus 2x is 5x, minus 4 is equal to 6 because our 0 pair is gone. Here we add 4 to both sides, gone. And now we have 5x equals 6 plus 4, which is 10. Well, how do you get rid of 5? You divide both sides by 5, and of course, x equals 2. But that's not good enough. You also have to find y. And so let's do this. Let's use a different color. Let's say that y is equal to negative 2, it doesn't matter which one we choose, negative 2x plus 6, where we know our x term is 2. It's the thing we just found. So from here, well, let's finish it out. We have y is equal to negative 2 times 2, which is negative 4, plus 6, and of course negative 4 plus 6 is 2. So when every point's made up of an x and a y, and our x value is 2 and our y value is 2, we just found out that our solution is of course 2, 2. Our algebra matches the graph. Alright, we solved this two different ways, graphically and algebraically. Let's move on to our third and final example. Please pause the video if you need to. Alright, here we are in our third and final example, and this is where we're going to bring it all home. We're going to really drive this point home. Check this out. We want to solve the system y equals negative 2/3 x plus 2 and y equals negative 2/3 x minus 1. Now notice, because this equals y and that equals y, these two expressions on the right have to be equal. And so we can say negative 2/3 x, and you know, I'm sorry, caught in this pencil mode, negative 2/3 x plus 2 is equal to negative 2/3 x minus 1. Now, some of you are pretty astute. You already see the answer. Alright, and hold that to yourselves. But right here, we have negative 2/3 x plus 2 equals negative 2/3 x minus 1. Notice we have our x's on both sides, and we need to move one of them. So let's go ahead and add 2/3 x, and we'll add 2/3 x to the right. Of course, that zeroes out, and wait a second, that zeroes out as well. We're left over with 2 equals negative 1. Remember, when your variable goes away, and you're left over with a false statement, which 2 equals negative 1 is a false statement. What does that really mean? Well, it means that this system has no solutions. And I want you to think back to Algebra 1. What would indicate no solution? Well, let's graph these really quickly. I'll use purple for this one right here. We see that our y-intercept is positive 2. We see that our slope is negative 2 over 3, meaning I'm going to go down 2 and to the right 3. And I can graph that line as such. And using a different color, red, we see this is negative 2/3 x minus 1. Wait a second. I go here to negative 1, my y-intercept. And I go down 2 and to the right 3. And you'll notice something. Guess what? These lines will never cross. And in fact, guys, that's why they have no solution, because the two lines never touch. And what do we call that? Well, we call that parallel. And you know what? You could have known that these two lines were parallel. You could have known that they would have never crossed. And you could have known that there was no solution if you had seen that they had the same slope. Alright, I hope this helps. I'll see you guys in our next video.